Yeah. Cool. Right. So yeah, so we have one more design pattern to finish off the structural, and then today we will look at the other one, behavioral. Yeah, we'll start with behavioral today. Yeah, so that's the plan. So we had a look at these facade and flyweight last time. Yeah, so today, yeah, anything to remember or any questions on those so far, or are we good?
Yeah, we're kind of good for now.
Sure, cool.
Yeah,
And yeah, and I think, I mean, we don't need to memorize all these. Um, just at least know that, I mean, these patterns exist, and
yeah,
yeah. So, and if you ever see or come across reading somebody's code, looks familiar, like, what you've seen here, then it'll make more sense, right? And then you can be able to follow it, with the pattern. Then you can say, you can see, the way the code is written is by
hmm
following this pattern. So I'll just quickly go into a decorator and have a look at the example lesson. I mean, this is what this does, and you can see the similarity in that person's code. And then it's
right.
easy to understand, so he's applying this pattern, so I can be able to see what's coming, and how these are going to connect together and working together and stuff like that. That's what I would say. I mean, the beauty of this, I mean, so we don't need to remember all these, and how to write this bit of example and things like that. Just to know these patterns exist and read it with it. So yeah, read someone's code with it, or write your code in a way you can apply the pattern to
Mm.
yeah, to make it a bit more cleaner, I would say. Yeah. Okay. So the other one, the last one from structural we want to look at is yeah, what is it? Proxy. Yes, proxy, right? The proxy design pattern. Yeah. What do we understand by proxy? Do we know?
Proxy. I've heard the term before.
Yeah.
It's like is it like okay, I'll tell you how I view it. Like I've heard of proxy wars, like
Yeah.
little wars before the big war.
Yes. Yeah.
I don't know if that
Yeah.
correlates to what we're doing.
Yeah. So yeah, correct. So some little things in front of the bigger ones, right? So or you could think of it like, I mean, in programming, right? If it's a proxy, that's something that we use for extended behavior again here, like you know, um, what is it called? The uh
Extension functions.
yeah, extension functions, adapter or decorators, so they were extending the functionality of something without creating a lot of class hierarchies, and also without messing up with the default class, right? So we were
Mhm.
writing in a way we can extend the functionality by plugging things or adapting to something or something like that. The proxy is the same, but the proxy will differ from the other design patterns because it'll totally take you into a different spectrum. So imagine, let's draw this then. Please, if we draw this. Um, yeah, so think of it like, you have yeah, you have some system, right? Um, and yeah, so say that this system can download some pictures for you. Yeah, download, right? So let's say this system you call to download pictures. So this system has to go to network, right? To the server, yeah, to get the picture for you. Yeah. But we will plug in a proxy in between these two to do something different. So we will have the system to download pictures. Client will request the system to say, hey, look, I need a picture for this URL I'm passing in. Yeah. Then this system you have will talk to the proxy and say, I have no idea what to do. Can you take care of this responsibility? And then this proxy in the middle, so it'll be always in the middle. So this proxy will check, do I have the picture for this URL coming in from this client? If it does have it, it will return it, right? If it doesn't have it, then it will call the request. Sorry, it will call the server and it will cache it here, so that the next time when it comes in, it can be able to give it from the cache. So the proxy deviates from what the system is expecting to do. So the system, the main request to get the URL from the server, right? So it's kind of deviating here and making a decision. Am I going to be lazily giving the picture which I have, which is because that's the picture the client as the system is requesting. You see my point? That's where we use the proxies, to proxy through to something else. You with me, guys? Hello?
Yeah, I'm still here. I'm still here.
Okay. So yeah, so there are proxy servers as well, which does these kind of things. They can be a main. They could be they could be a client, our mobile phone, our app, and then there will be there will be servers here, which the server nodes. There will be lots of instances of servers which will have the APIs to serve requests. So this could be API 2 and 1 and this and that. So the client doesn't go direct to these. So the company would probably have a proxy, API proxy, in between the servers, and this talks to the proxy, and then the proxy will check what's this request for, whether this is for API 1 or 2 and this and that, which internal service I will need to call now to get the response. And this will call that, it will receive the data, and it will package the data it's getting back from the internal system, which is the API 1, and it will send it to the client, respond to the client that this is the response for you, the request and response, right? So the proxy stay in between. So if you ever want a proxy in between, you can think of a proxy design button, to offload the responsibility of a system, in this case like this. So if you don't want to expose this, and if you want a proxy in front of that, something like a cache, something like a cache, but its scope is a bit more than caching. It could do other things too. Like in this case, it was caching and checking whether it needs to get the data from the cache or call the network. So it could ideally use the cache design pattern. It can to talk to the cache. That's your cache. What is the cache design pattern? It's what we studied, the facade, right? Remember the caching example we saw, and if that cache is complex, you can talk to the cache through a facade. So the facade will make it easier for you to understand what that system behind you. So it will simplify the calls. So you will call those calls, rather than exposing or rather than talking to the actual complex system. That's the responsibility of a facade. Remember, we studied last time. But the proxy in this case is making decisions for you. Whether to call the network or whether to get it from the cache. So okay, you guys with me? So the system is calling the first accessing the proxy. The proxy, let's focus on this example then. So a system is needing to get download a picture with a URL. So the request comes first to this proxy. We have this design pattern in place. So proxy is the first one which receives the request, and it will check whether this picture is already available or not. If it does, it will get it from a cache. So how can we talk to a cache? We can talk to a cache through a facade. So now this is our facade design pattern coming in place. So this is our complex cache. This could be doing a lot of things, which we don't care about, but the facade is the one which will, which will receive the request in this case, to say, okay, I'm accessing the cache to get something for you, and it gets the stuff from the cache and it'll give it back to this thing. This thing will see, okay, I've got the cached object, give it to the client. If it's not in the cache, it will make the decision to say, I'm the proxy, so I'm going to still serve the request. So I'm going to call the network to get something, get the actual raw image, And when it gets it, use the facade to store it to the cache, and it will return it back. See how many design patterns are coming in place together? Proxy, facade to talk to complex objects, in this case, a complex cache.
Okay, yeah.
You see what I mean?
Mm-hmm.
So, see, design patterns, we're seeing the patterns in action together.
Combination of design
patterns. Exactly. You see? Yeah, things like that. So if you want to put this as an example, the facade, sorry, the proxy, we can simply think of a data class, sorry, not a proxy. Let's say this is the one which is going to download the images. So images can, this is the one. No, yeah, this is our data class to give us the images, right? And we can think of it as, I mean, we can give image URL to get the image. So that could be string. And then, yeah, let's have the body of this class. We can say this is our image, which we want to return, which could be the byte array or something. So that this is the raw bytes that we want to return. So how do we access the proxy here? We can use the by keyword, and we can say by lazy, the keyword for this. And you now need to read the URL and give the thing dot, sorry, URL or something dot, actually, yeah, URL with this URL created, image URL, and then dot read bytes. Yeah, okay, there you go. So see, simple thing like this, which is actually kind of doing the proxying here. So if I ever use this data class, I'll need to give a URL, right? And I will call this to get my byte array for that. Yeah, the actual byte array for that image. So it's seeing, so the by lazy, what is that doing is it's creating the image URL. Yeah, is actually making a client request here, HTTP request, because this is a URL. Imagine that's actually making a retrofit call and all that, right? For this given URL, it will call the network and it'll read the bytes. That's what the image is now. But because of this is behind the by lazy, the next time when you call this, it's going to just return the image rather than going into this block, the body of this this block, yeah, because it's by lazy. By lazy means only run it for once, and if you have it, just return the value. If the value is null, or if the value is null, then run what's inside this block. That's what this by lazy means. See, with Kotlin's by lazy, we can achieve, the proxying design pattern here. So always return this if it's already fetched by that. If not, then run this by lazy. That's why this is called lazy, because it's not going to always run. It will only run for the first time when the image is null. You see my point? There's a simple example like this from this book, So you can use by lazy in Kotlin to run not every single time.
It's got a name called delegate or something. I'm not 100% sure.
But... yeah, by is the delegation. Yeah. So here, the lazy implementation is the delegation on this, so we are delegating to a lazy call, so by is the delegation. You can delegate to anything, but we're delegating to a lazy block. So byte array will be received by the lazy block, which in this case, because of this is lazy, because of it will only run when this is first time fetched, first time called, and because it's a value, it will then always have it, because if you have it, you'll return it, right? If it's not, that's why it's lazily fetched, yeah. So this second time, if I call this, I'll get the same image for the same, because of the URL is the same, right? And if I pass in a different URL, yeah, that's a different story, because that image is not there, so it will run the lazy again to fetch the URL. the byte array in this case, for that URL. You with me, right? Yeah, but that's the example in this book I've seen.
Okay.
Yeah, which is Alex is showing, and I can see. I mean, that's the best way of putting the Kotlin by lazy.
So what's the proxy? What bit is the proxy?
Is the whole thing, the by lazy, because of, okay, so if you want to get the image, you're delegating to a lazy call, right? That means
Delegation means I'm asking it to do something.
yes, correct. I am delegating to get my byte array in this block.
Okay.
In this case, a lazy block. Lazy block is there to only run for the first time, right? It's only when this is accessed, it will run this. Yeah. And then second time, when we access the image, it will not run because the image is already there. So we will just access that value. Yeah.
The benefits of that, is that for memory?
Correct. Yeah, because we've already fetched it, right? So we call the URL read bytes to get the image bytes. So we've got it already. So that's at the very first time, when the image wasn't, when the bytes were not fetched. Yeah. Yeah. So yeah, that's that thing. But hold on, let me refresh my memory here to add anything here or not. Hold on, just give me 1 second, please. Yeah.
Yeah, no problem.
Yeah.
Is Cherif still there?
Yeah.
I'm there.
Yeah.
Okay. Yeah, no, I was going to ask you, do you work in Kotlin at the moment?
Not yet, but I work in Java.
Okay. So this by keyword is new.
Yeah. But I know a lazy concept in some Hibernate like in frameworks. I have used that.
Okay.
Yeah. So yeah, it's you can't say this as a lazy delegation. By is delegating, right? Because we are saying image, I want the image bytes, but where is it? You're saying get it from here. So that's why you're saying by. Where is this coming from? By lazy delegation. So the lazy delegation in this case, I mean only run it when I'm asked for the image bytes. Yeah.
Yeah.
And the second time, it will not run because I mean it's been fetched already. Yeah. Yeah. Because there's a val, right? So second time when I ask, because of it is assigned to the bytes fetched, so it will just return it. First time it will be it's nothing fetched, so it's null. So that's where it'll see, okay, I have to run this block of code. Yeah.
Can you show it in your diagram that you just drew?
You mean this? You mean?
Yeah. Is it?
Oh.
Can we see it happening anywhere here?
No, this is kind of, I mean, telling the proxy example, right? So yeah, so we put our, yeah, kind of here. So we put our lazy delegation here, right? So we said, so the data class itself is being the proxy for us, right? So we said, we given the URL and said, no, we'll fetch the byte array for it. And the proxy in this case here with our lazy delegation, it first checked it's the, there is no byte array. So it executed that line, this line URL read byte. Yeah. So it actually the meaning of that is, I mean, it actually made a HTTP call to get something, the read bytes out of that. Once it got the bytes, we return the value with the bytes. Yeah. Second time when it came in, the lazy delegation sees the val is not null anymore, so we just return it. you know.
Okay.
Yeah, here, because the image is not null, right? Yeah. Yeah. Okay.
Yeah, I understand it a little bit more now since I've seen it correlated
Yeah.
with the
Yeah.
example.
Okay, let's put some println here to make it sure that's what this is exactly doing, calling lazy delegation. Yeah. Okay, so if we have a main function and if we call this image URL thing, and then let's give it a URL. Yeah, that's our URL, right? So now we're calling it. Let's see. So okay, so that's the data class that has an image, right? This is the image URL, and now we can call image URL dot image. So this is what we are getting. We are reading the bytes from, right? So if I call this, I will need to see this is executing because this is the first time I am accessing this, right?
Yeah.
Second time, if I call the same, I should not see this printing, right? Let's see then. It should be printed only once. Yeah, think of this as, I mean, this will be only run for the first time. Yeah, that's why it's lazy, right? Second time it's not going to run it because it's lazy. See that? Only once.
Right.
How many times we call this? You know, that block is only going to run once because that's lazy, right? But we are delegating to a lazy delegation to get the byte array, which we only fetched once. Yeah. And then every other time after the first time, it will just read what's been fetched already because of this block will not run because of it's lazy. Yeah, that's Kotlin concept. But we are achieving with the lazy delegation a proxy here. You know, the way we are building a proxy is this. You know, we will see if this is not fetched already. We will run the lazy block to get the URL, to actually pass the URL to get the bytes. Then always return this, you know, because we fetched it already. Yeah, you see what I mean?
Yeah.
Yeah, that's it. That's kind of proxying. We can see other examples as well, but I couldn't think of anything. I'm just going by the book, you know.
Yeah, yeah. This seems cool.
Yeah, because it's really nice to see this lazy block, you know. Only run once, you know. Yeah.
That by keyword, could that be used with another block instead of lazy?
Yeah, correct. You can put it with anything. But you have to call a class or something to, you know, actually go there. You know, remember this where's this? Not the builder, decorator, I think. You know, we were delegating to things. Yeah, here. There, you see? By. So
Okay.
creating a shopping cart, which extends the shopping cart, but this is what we are calling as logging shopping cart because this is going to do logging, but we delegate the actual implementation of that to a default shopping cart. You see? Otherwise, you have to implement all these interface gives you to implement, right? So we tell all that implemented on the default shopping cart by telling delegate the implementation of the shopping cart to this default one, which we receive as part of creating this. And then we just only overwrite the ones we want. That's how we don't mess up with the default shopping cart, which is here. Yeah, not that. I mean, the default shopping cart will pass it at the call site, the default one, you know, here. So this stays the same always. You see?
Okay.
Yeah, so that's another delegation, but in this case, it's not a lazy delegation. This is a object delegation, right? So we are delegating our implementation to another object, you know.
Okay.
Yeah, by is for delegating. Yeah.
Mm-hmm.
Yeah. But in this case, this is a lazy delegation because of it's using this lazy block, you know. So it'll only run for the first time when it's accessed. You know?
Okay. Yeah.
Simple as that. Right. So we're done with that, and now we can move to the behavioral, right? So we have so far seen all these design patterns, right? And so first we saw the creational one. So we saw some factories, like, you know, how a factory can be used to create objects, you know.
Did you want to stop this one and start again?
Oh yeah, man, that's true. Good point. Good call. Yeah, let me stop and start again. Yeah, because it's going to finish anyway in eight minutes.
Yeah.
Yeah, cool.